and with chapter 1, we're going to think about introduction, inequalities, and absolute value, right? So with chapter 1, we're going to take introduction to row number system, and also we're going to take in inequalities, and we're going to take absolute value. So now, chapter 1 starts with row number system. So under row number system, you have something called the introduction to row number system. Now, the set of natural numbers. So we have type of numbers under row number system, right? Which is, we are going to talk about the natural numbers. So when we talk about natural numbers are numbers that start with 1, represented by n. So it's like this: 1, 2. So these are natural numbers, and they start with 1. Yes. So whenever you hear anything about natural numbers, it means that they are numbers that start with 1. They are under the row number system. Now, let's read this here from the notes I'm reading here. They said that this set is closed under addition and multiplication. Now, one may ask, what is a closed set? So they say this set is closed under addition and multiplication. What it means is that when you take any number of this and you add them, you're going to get a natural number. So for example, let's take addition. So 2 plus 3, which will give you 5, and 5 is found in natural numbers. That is what it meant. And when we take two numbers and multiply them, we are going to get a number which is what? A natural number. That is why they say it is closed under addition and multiplication. But it is not closed under division. This is because when you divide it, you're going to get decimals. And with these numbers, natural numbers start with 1 and end at infinity, right? So it means that it's not closed under what? Division. Yes. Now, we have another one which is called the whole numbers. So whole numbers are numbers that start with 0. So whole numbers, they start with 0, 1, and they end 0. So whole numbers are numbers that start with what? 0, and it is represented by W. Yes. So whole numbers start with 0, and it's represented by W. Yes. So we have this is called. So we have two things, which is called the rational numbers and the irrational numbers. Yes, rational numbers and irrational numbers. Yes. So with rational numbers and irrational numbers, we have z, which is equal to ... -3, -2, -1, 0, 1, 2, 3. Right? So which is called the integers, right? This set z is closed under addition, multiplication, and what? Division. So with z, which is the integer, you know the number line, right? So the integer is the number line which starts from negative, middle is 0, and ends with positive. And with this set, it is closed under addition, multiplication, and what? Division. Because when you divide, you know that between -3 and -2, there are numbers in between, right? So when you take any of these numbers and you multiply them or you divide them, you're going to get the same numbers in the integer, which means that with the integers, they are closed under what? Multiplication, addition, and division. You should note that. Now, when you move down, further explanation, that's further extension of this set is include all fractions, both proper and improper fractions. So which give us that Q. We are moving on to something called Q. Is equal to A over B. And when we talk about Q is a rational number. So a rational number is a number in which can be expressed as A over B. It can be expressed as a fraction. That shows that it's a rational number, right? So it can be expressed as a fraction. Now, so any number which can be expressed as A over B, it means that it's what? A rational number, right? Yes. So a rational number is closed under all the arithmetic operations. So a rational number is closed under multiplication, addition, division, all the operations. So rational numbers are closed. It means that when you take a rational number and you multiply them, you're going to get a rational number. When you take a rational number and you divide them, you're going to get a rational number. That is what it means under closed, right? Yes. Now, we're moving on. In case the under addition is divided by 0, must be avoided. So what it means that this should not be equal to 0. It must be avoided. That means this is not equal to 0. Yes. So now, irrational numbers that is Q can be expressed as A over B, whereby B should not be equal to 0. Yes. So from that reason, it means that 0 is a subset of Q, because Q can be expressed as A over B, where B should be equal to 0. That's the first thing you should know. And Z is a subset of Q. And also, so from this reason, it is clear that N is a subset of Z and it's a subset of Q. This is the most important thing you must know, right? This is the most important thing about what I taught. So basically, in exams, they can ask you this as an object, right? So this is the most important thing. And also, you must know that we have the natural numbers, the whole numbers, the irrational numbers, the rational numbers. Okay, with the irrational numbers, it's the vice versa of this. With irrational numbers, it cannot be expressed as. So irrational numbers cannot be expressed as what? A over B. So for irrational numbers, it cannot be expressed as this. So for a number that cannot be expressed as this, it is same as what? The irrational numbers. So you should take note of that, right? Yeah. So you know how to represent integers on the number line. So without just write number line and represent. So this is the number line, and A becomes 0. This is the negative, and this is the positive. You should know that, right? Yeah. So what you're going to talk about now is you know, with integers, we have the positive integers and the negative integers. You should know that. And 0 union, the positive integer becomes a whole number. So the 0 union, positive integer starts from 0, 1, 2. So it becomes what? A whole number. So you should know that. Yeah. So we are going to talk about irrational numbers. How we identify whether a number is a rational number or an irrational number. That's what we're going to talk about. So be with me, let's do this. So, for a number to be a rational number, right? Yeah. For a number to be a rational number, it means that can be expressed as A over B, but for irrational numbers, it cannot be expressed as A over B. So, let's look at this. We are proving that root 2 is an irrational number. So, we are proving that root 2 is an irrational number. And when we talk about irrational number, it means that it cannot be expressed as A over B, but the assumption that we're going to do is that we're going to use the vice versa. So we're going to prove that, assume that root 2 is a rational number, right? Yes, so first thing we do is that root 2 can be expressed as A over B. This is the first one. This is an assumption we're making. Then, what we now do is that we're going to, let's try to simplify this. So this will be squared, and this will be squared. So this will cancel. So you're going to get 2 is equal to A squared over B squared. Then, you're going to get A squared is equal to 2B squared. Yes. And when you do that correctly, now for us to do, now, we know that A squared is equal to 2B squared, right? So, A squared is an even number, right? So it means that A will be an even number. If A squared is an even number, A will be an even number. So we're going to do some assumption. Let C be equal to A. So let C be equal to what? A. Okay, let's let A be equal to 2C, right? So we're going to let A to be equal to what? 2C. So if you put that 2C squared is equal to 2B squared. So you're going to get 4C squared is equal to 2B squared. Therefore, B squared is equal to 2C squared. And since B squared is an even number, A is an even number. This is an, so that's right. Since A is even and B is even, it implies that A over B is not in the least form. Right, so first you want to do that, just assumption, you're going to make an assumption that this can be what? Rational number, which can be expressed as A over B, where B is equal to 0, then you simplify, you get this. Now, do this A squared is equal to 2B squared. Now, with this, we are A is an even number, therefore A squared is also an even number. Here, I'm going to make A equal to 2C. It's an assumption, right? So whenever I get this question, you're going to make it equal to 2C. And when you substitute, you're going to get 4C squared is equal to 2B squared. And when you simplify, you're going to get B squared is equal to 2C squared. So A is an even number and what? B also is an even number. Therefore, A over B, it is not in what? Its least form. Now, before a rational number becomes a rational number, it must not be in a, for rational numbers, it's not in the least form. So, for example, 4 over 2 is a rational number, right? But with irrational numbers, it must be in its least form. So, since A is a even number and B also is an even number, therefore, A over B is not in the least form, therefore this is what an irrational number. So you can try this. So try this as the normal way we did. And you know that with root 3 is what? An irrational number, right? Yes. So we have another example, 1/2. Now, for rational numbers, they are recurring, right? So when you divide a fraction, you know that they are recurring. It's what? So every rational number may be expressed as, so you must know this. Every rational number may be expressed as, that is 1/2 is a rational number, 0.5, and also 1/3, you get 0.333. So 0.3 is also a rational number. So note this, all rational numbers can be recurring numbers. So if you give you a fraction, when you do the long division, you get that the number is recurring, then this is what? A rational number. But with the irrational numbers, it's continuous like, you know that pi is an irrational number because pi doesn't end. So certain fractions, when they give it to you and you try to divide them and you start the number, it's not ending, but it's continuously adding more numbers. Therefore, that one becomes what? An irrational number. You should note that. So example of irrational number can be 2/3, and also example of rational numbers can be 4/2, and we have a lot, right? Yes. So let's continue. So we have certain rules that you must take in this thing, that is the operation with the number system. You have rules and then that you must know. And these rules are very important, and when it comes in exams, you must know it as your fingertips. I know these rules is somewhat simple, right? So the first rule you must know that we have the closure rule. I talk about the closure. That is, it's if the set is closed under certain thing, that when you add them, you should have the same number of that set in that universal set, right? So we have the commutative property. What is the commutative property? A plus B is equal to B plus C. So the commutative property is for both addition and multiplication, because 2 times 3 is the same as 3 times 2 and give the same answer. We have the associative property. Now with the associative property, look at like that. So it will be A plus B plus C is equal to A plus B plus C. When I close this, and also I close this, they are equal. This is the associative property. Note that. Now you can, if they give you a question, you want to test whether it's associative property, you can take your numbers for A, B, C, and check whether it will give you the same answer. And if it gives you the same answer, when you express it like this, and it gives you the same answer, it means that it's what? An associative property, right? Yes. We have the commutative property for multiplication, which is A, B is equal to B, is the same for the commutative property for addition, multiplication. Now we have something called the distributive property. With the distributive property, A into bracket B plus C is equal to AB plus AC. So if you can express as this, now when the number is given to you, you're going to take your numbers and you express as AB plus BC. You're going to find this by this, by this. You're going to get this. So that's what the distributive property. So you should note that. And we have the identity property. You know that any number times 1 is the same number, right? So A times 1 is equal to 1 times A is the same as A. You should know that that's the identity property. And we have the identity property for multiplication and for addition. For addition, you know that A plus 0 is equal to A. And for multiplication, A times 1 is the same as A. So that's the two under the identity for multiplication and identity or addition. There are more to this that you can find, yes. So you need to find those things. Now we are moving on to, this is my PDF reader. I'm using my small yam to read my PDF. Yes, it's very powerful. Yeah. So we are going to inequalities. So inequalities. So we are done with the first subtopic. We are now moving to inequalities. Yes. So for inequalities, we have some. Let A and B be a subset of R. Then A minus B is positive and blah blah blah. Under inequalities, we have some properties that these properties are very good to know and they normally come in exams. So we're going to look at the theorems in what? Inequalities. So the first theorem is that if A is greater than B, then A is equal to B, or A is less than B. The first one you must know, this is the first one. Come, let me take the marker. So this is the first one you must know, that if A is greater than B, then B is equal to, then A is equal to B, or A is less than B. That's the first theorem you want, the inequality, right? The inequality. The second one is the law of this is called this law of trichotomy. So the law of trichotomy says that if A is greater than B and B is equal to B, then A is equal to B, or or A is less than B. You should know this is a law of trichotomy, right? So the law of trichotomy states that if A is greater than B, A is equal to A should be less than what? B. Then the second law states that, so please note this, the second law states that if A is less than B and B is greater than and B is less than C, automatically will be greater than C. This is it is if A is greater than B and B is less than C, then A is equal to A is greater than what? C. And that law is called the transitivity. Law of transitivity. So with the law of transitivity, it says that if A is greater than B, B should be less than C. Automatically it will be greater than what? C. That's the law of trichotomy. And the law of transitivity, right? The next one you should learn is if A is greater than B, then A plus C is greater than B plus C. This is also goes. You can put in number, right? You see this. And the last part want to see that if A is greater than B and C is greater than 0, then AC C is greater than B, AC is greater than BC. And the last one is if A is greater than B and C is greater than less than 0, then AC is less than BC. These are all rules you need to know about the inequalities. These rules normally come with exams and they can ask you, the first one is this one, the next. So you should know that the law of trichotomy and the law of, is it trichotomy? Yeah. And this is transitivity. Absolute value. What you must know with absolute value is that it is denoted by x. Yes. So it is represented by x and a 2 bar. Now when we talk about absolute value, we have some rules and the absolute value must know. That is equal to if x is positive, if x is greater than or equal to 0 and x is negative, x is less than 0. So these are the rules you must know that if x is positive, the absolute value of x is positive if that value is greater than or equal to 0 and it is negative if it's less than this if it's less than 0. So this is very simple to understand. So it means that let's take 2. We find the absolute value of 2. 2 falls here, right? So it is what? 2. Because 2 is what? Greater than or equal to 0 and it's greater than 0, right? So the absolute value of 2 is 2. Now let's see something. Now when we talk about the absolute value of a negative number, it's going to give you negative 3, which is going to give you positive 3. Note this. Let's see something. When it is negative, so the absolute of this is negative and it's having a negative, so it will make it positive. And with absolute of 0 is 0. Please note this, that the absolute value of a negative number is positive, and the absolute value of a positive number is positive, and the absolute value of 0 is 0. Now the reason why you write lane with absolute is because lane, you cannot take the lane of a negative number then, but you can take the lane of absolute number. So if you take a lane of negative 1, it's the same as for lane 1. Note this, you'll be doing this in, I think, chapter 3 or 4, so or 5. You'll be doing this. So this is chapter 1, right? Now let's go on. So the absolute value of a negative number is positive. You should know that because they say if x is less than 0, it is negative. So it's negative and it is having a negative again, which will give you positive. Now let's move on to some properties you must learn from absolute value, right? So these properties you must learn them very fast. The first one I'm going to learn about is the absolute value of x and y is equal to x and y. So absolute value of x and y is the absolute value of x and absolute value of y. Let's go. The absolute value of x plus y should be less than or equal to the absolute value of x plus the absolute value of y. And this is called the triangle inequality. So take note of this. When it is the properties like this, it is called a triangle inequality. Now, let's take this. When it goes to minus, the absolute value of this minus y is either equal to the absolute value of x minus the absolute value of y. Please take note of this. Take notes. Are you getting it? Yes. In exams, they can bring this as an object question, and you should take note of this, right? So the absolute value of x minus y is the same as is what? greater than or equal to the absolute value of x minus the absolute value of y. And note this, the absolute value of 0 is 0. So let's say the absolute value of 0, or the absolute value of x is 0 when x is equal to 0. So these are the properties under the absolute value, and you should know this off here, right? So we have 1, 2, 3, 4, 5. Now we didn't talk about inequalities, so we're going to learn how we can solve inequalities and bring what? So with inequalities, we talk about inequalities, right? Now we're going to learn how we can solve inequalities. So we should find the value for x. So I find the value for x, for which x squared minus 3x minus 2 should less than 10 minus 2x. The first step you must do is that now with inequality, this is x is an interval. So we are not going to look at x as one value, but x is an interval. So it has a value, it's an interval, right? So this answer for x will be 1, it's an interval. So now what to do, they just simplify this. So when you simplify this, you're going to get x squared minus 3x plus 2x minus 10 should be what? Less than 0. And this is going to give you x squared minus x minus 12 equal to 0. Now you do this with your calculator, and you can do that, and also you can use quadratic equation to do this. So when you do that, you're going to get x minus 4 x plus 3 should be less than 0. Now this is where the issue comes from. Now when you get here, it means that how we got this is multiply this by this, find the two values that will give you this, and we have this. So with this, it means I'm going to find the value. Now from here is, take note of this one, so we are going to find. So from here, you know that we are going to get x should be less than 4 and x should be less than -3. So this is the interval, right? In fact, this is not the answer. You must test that the answer is correct. So what you do now, you're going to test. You see x is less than 4. So let's tell you the negative. X is less than 2. Which numbers are less than 2? We have -2, negative. So x is less than what? -3, right? It may have -4, -5, right? This is something. And this is x is less than 4. That is 3, 2, 1. So now I'm going to test that if you are testing from here, if you put in -3 here, what will you get? You are putting negative, you are testing -3. When you put -3 here, this will be 0, and that's not possible. Then let's try -2. When you put -2 here, it will give you a number which is less than what? See, it will be less than 0. Test for it, it will be less than 0. That means when you put -2 here, the answer will be less than 0. It means that -2 satisfies this equation. Now look at it. When you take -4, it will make this one be what? It's so, let's say -4. It will be positive. So -4 cannot satisfy this equation, but when you put -4 here, it will be positive and it will affect this, right? It will not be less than 0. So when you take -2, it's in a -2 holds. You can test for it. When you put -4 inside, it will make it positive. It's less than 1, 0. It's not possible. So it means that the interval for this is what? X should be what? Less than -3. It means that the interval starts from -2, right? So x should be less than -2. And now let's see something. It means that x should be greater than -3. Because when x is greater than -3, we put -2 inside, it's satisfied the equation like to be low. It will be less than 0. When you put it inside, when you get less than 0, right? Now let's test for the top one. If x is less than 4, when you put 4 inside, let's try 4. When you put 4 inside, it's going to make this one 0. And 0 is not less than 0. It's not possible, right? So you're going to take in another one, which is x being less than. So when you put 3 inside, 3, it is less than 0. Because it will be 3 minus that, which will be negative number, which will be less than 0. So the interval that we found was x should be greater than -3 and x should be less than 4. You see, it's different. Because when you test for it, when you put x should be what? Less than, if x is less than -3, it means you're going to get -4. When you put -4 inside, it will not make this one less than 0. But when you put -2, which is x is greater than -3, it will what? Make this equation verify. So it's like when you're writing, you're going to get -3 x less than 4. This is the interval you want. This is the inequality answer. It means that when you're putting it, you're going to get negative 2, negative 1, 0, 1, 2, 3. So that when you put any of these numbers inside, it's going to satisfy the equation. That's why I told you that the inequality, when solving it, is an interval. So first, when you solve, you get your answer, and then you test. You're going to test whether when you put, you are going to test for the first one. You will start with negative and test for the positive. Because when you test it, s is less than negative 3. When you put negative 4, it's not be equal to what? It's not be less than 0. It means that that's not part. Then let's go to when it is greater than that. You put negative 2 inside and satisfy the equation, and you test for it. So this is how we solve the what? The linear inequality. So you can try your hands on more and you test for it. Thank you very much for watching this video. Please can you